Okay. Jason, did you get a chance to watch last week's?
I did a little bit, yeah.
Okay, cool. So we covered compilers, interpreters, and just-in-time compilers last week. We covered, source code, machine-readable code, CPUs, multi-threading, parallel processing, and now we are jumping down into. Let me make this full screen. There we go. We are jumping into more of a broader look, and then we'll jump into networking. So the broad look here is, I said this last week, but when my wife's a software engineer, and she's been so for 3.5 years or so now. And when she was first looking at getting into the field, I actually drew this exact same diagram. So I think it's useful to describe kind of computer science and software engineering through this lens from a practical perspective. So first thing is in the upper left quadrant, we have web development. Web development is kind of its own field in a lot of ways. All these are interrelated, but if you come across someone who specializes in web development, it's unlikely that they specialize in robotics and embedded systems or data science. People kind of end up going down one sort of specialty lane a lot of times. And then there's also data science in the upper right quadrant, which are data science and desktop apps. I kind of lump those together. Desktop apps like Microsoft Office, for example, or you could build some sort of a simulation suite that's a desktop app, et cetera. And then robotics and embedded systems. Maybe the hardest of the three is in the bottom left. And then on the bottom right is networking. And that's not really a software engineering field. It's more of an IT field or networking specialist field, but I like to include it because it's so fundamental as it's kind of its own thing. And there are important concepts to understand. So where does Epicai live? Well, Epicai does all this stuff, but primarily lives in the robotics embedded systems world, and really less of the embedded systems and more of the robotics. However, we have interfaces with like networking, with web development, and with data science. Networking for like making our drones connect in the air, web development for the front end user interfaces, data science for like analyzing our algorithms to make them better. We don't really do desktop apps. I don't think at all at Epicai. We do a ton of robotics and very little embedded systems except for CSRF. Let's talk about the difference between embedded systems and general computer systems real quick. Embedded systems are when you're compiling code literally onto the hardware. You're not using an operating system in the mix. Things like VHDL programming, FPGA, etc. And that's a whole specialized field where people can actually program on these embedded system devices. Usually it's done in C, bare bones C, and you're compiling to a target platform processor. You could also do it with something called assembly language, which is extremely low level. So where you're actually like moving things around on the processor cache and you're like specifying how it computes. So that's kind of the difference between those two. Let's talk about web development and kind of go through these in a little bit more in depth. So if I zoom in here, web development languages that you'll hear are a lot of scripting languages: JavaScript, TypeScript, and then also databases for storing information: SQL or SQL, Postgres, and then in the web development world, you'll often hear things that are called front-end and back-end languages. Front-end is like the user interface GUI side of things, but it's really the code that gets loaded onto your computer. And then back-end is the code that sits on a server somewhere far away. Back-end languages tend to be C# and Python. You can use Java or other back-end languages, but those are most common, sometimes Ruby. And then your front-end languages tend to be like scripting languages: JavaScript, TypeScript, etc. And there are package managers and other things that go with that, like Node.js. There's a couple other ones. And so it's kind of its own field in that respect. Let's talk about, all right, let me talk about frameworks, and I'll talk about a couple nuances with it that are important to know. So frameworks, there are really three common web development frameworks: React, React Native, which is a variant of React, and then Vue and Angular. NCA Stack is built in Vue. All of Applied's tools are built in React. Vue and React are reasonably similar. Angular is a little bit different and more of a beast. I've never actually used Angular. I've used both Vue and React. So when you go to load a web page, this is where we get to some of the fundamentals. When you go to load a web page, what happens when you type the URL address in the URL in the address bar? You click search. The web browser then sends a request over what's called a REST API to a server somewhere. The REST API or RESTful APIs are APIs that can do really one of three functions. They can send something, they can request something, and they can update something. This gets into fundamental computer science, which maybe we'll talk to at some point, but you'll hear those as put, pull, and something else. I can't remember what the other one is. You can Google it right now and find out. But REST APIs are essentially a little bit of JSON code, looking code that you send to another software program on a different server to tell it that you want something. And there's all kinds of APIs built around REST APIs. So when you hit that URL, it sends a request to get a web page, and it sends it to a server. That server says, "Hey, I have some front end code, and including, let's say JavaScript, and then some CSS and HTML code." HTML is just like hypertext markup language. It's how the web browser knows to display the information. And then CSS is like styling for HTML. So if you want it to look a little bit fancier with colored boxes and stuff like that, you have a CSS or a CSS file. So having both HTML and CSS sent with a little bit of JavaScript code is your front end, and it shows up as a little package in an IP packet, and the web browser deconstructs that and then displays the web page. Now there's still back-end code back on the server that's not being sent to you. Only the front-end stuff gets sent to you, but the back-end code is used to do the heavy crunching. So the front-end code, you might be like, on Google and or Amazon, you might be typing in like, I want to search for this information, right? Well, when you hit the button to search, the front-end code will then send a pull request or a get request, I think is what it is in REST API, to get information from the backend server. And the backend server will do heavy crunching with C# or whatever it's written in to, catalog all its information, and then it will send updated, probably a data object of just like JSON back to the browser to display, and then it will update its styling to show you what's on the web page. So that's kind of how the front end and back end stuff works. It gets very deep, very quick. All the front end stuff is interpreted for the most part. Now, React and Vue and Angular are actually compiled, and they're compiled in a way that they're still sending interpreted code to the web page, but you end up building the back end and front end components together in one framework, or you can at least. That's about the extent of my web development knowledge. I've done a few web projects throughout the years, but not a ton. Are there any questions there? All right.
I think I'm good. I guess one question. So maybe I'm missing the connection. You were talking through like REST API being the sender and the receiver, and the frameworks. Are those frameworks users of the API, or are they APIs themselves?
The frameworks are just like, think of it almost as an integrated development environment. Like, have you ever pulled up Visual Studio, like the real Visual Studio? It's almost like that.
Okay.
But it's really web-based. So if you start to build a React app, here, we'll go GitHub.com/card. Let's do this chess web app. When you go to build a React app, you will go into the command line and you'll kind of say something along the lines of like node package manager install React and node package manager initiate a React app. And it will then download all these files, right? All these preset files that are really in this source container here. And then it's up to you to go into those files and change all the information. So like the primary source file here is it app.js? Which one is it? Probably index.js. Really? Oh, game.js. That's where it's at. So it's up to you to go in here and change all the information and say like what you want to be displayed when, what states you want to change, etc. And then you say like node package manager, like start, and it will then run a compilation step, compile the code, and then it will start displaying it on the web browser at like localhost, whatever. And you can also do like node package manager deploy to this IP address, and if it's configured correctly, it can deploy the web app. So a lot of it from a user perspective, developer's perspective is like kind of abstracted. But what I told you still stands. When you go to like search something, it shows up in a certain way. Now, what I wanted to show you is I go to Google, just good old Google. You can do this on most modern web browsers. You can right click and click inspect, and you can actually see some of the source information that's there. Probably, oh, there's nothing in index. Oh, here's the HTML. So there's a division, a style, some code. There's probably a script like JavaScript in here, some function, get Google, a bunch of information. So like that is being fed from the Google server to the front end web browser and then displayed for me. And I can kind of inspect the front end elements while they're here. Does that help, Justin?
Yeah, thank you.
Cool. There's probably some really good YouTube tutorials too. I haven't looked at a lot of them. There's really good documentation in the web development world, and web development tends to be easier in some ways. Maybe not from the back end front end confusion, but from a language typing confusion. Usually they don't do object-oriented programming. It's very functional. It's very clean. There's no static types. We'll talk about that stuff later. Okay. So we'll move on to desktop and data science apps now. So languages that are typically used here are C#, Java, C++, and Python for the most part. You could do C++, but I would say that most of the time it's actually C# and Java for desktop apps, and then Python for data science. Frameworks that are used, so C# uses .NET, Java usually uses Eclipse as a framework if you're building a desktop app, and then Python uses Anaconda as a tool if you're doing data science, which is like an IDE for developing Python scripts for data science reasons, and it has a whole community. You can like upload your scripts, download other people's scripts and stuff. And so why is Python used for data science? I think honestly, because it's really easy to type or really easy to write. Python's very easy to write, but it's not used for desktop apps because C# and Java are significantly better for that type of use case. And the .NET and Eclipse frameworks are significantly better, and they come with a lot of UI components and a lot of really fancy stuff you can do with the languages. C# and Java and C++ are all harder than Python. C++ is harder than C# and Java. We can talk about why a little bit later. Robotics and embedded systems. Any questions on desktop apps or data science? Cool. we will jump to robotics and embed systems. So, from a like, let's call it like actuators and sensors and moving stuff around, and like in the robotics world, the languages that are typically used are Python, C++, Verilog, VHDL, and FPGA. Those three are only used for the embed system side of things. For the robotics side of things, it's really C++ and Python that kind of dominate the world. Occasionally, you'll see Java, but that's very rare. In terms of frameworks, these are really compilers, but you have C, C++, Clang, and then from a build system, which is really a C++ism, you would use CMake. And if you, we'll maybe talk about this in a little bit, but like the difference between compilers, translate the information to binary. Build systems actually configure all the files. It's like a pre-compiler step, configure all the files for compilation. And so CMake does that, and you have to do that in C++ when you have a bunch of different files, and that gets into like really deep stuff that we could talk about at a later date. So that's what dominates the robotic systems world, or the robotic systems world, including things like trains and automobiles and airplanes and power systems and power grid systems. Like these type of languages rule the world. SCADA is another language you'll hear, and ADA is another language you'll hear. SCADA is really used for safety critical systems like power grids. ADA is used for satellites for the most part, and they all have their benefits and pros and cons. Networking, let's jump to that next. So in terms of networking, I've broken this down to protocols / data formats, if you will, and then tools that are used for them. In terms of protocols, internet protocol or IP protocols rule the day these days, but actually in defense, there's some other ones. IP stands for internet protocol. It has two different variants. And an IP, protocol is when you send something. So there's two different ways to send IP packets. There's TCP and there's UDP. TCP is transport something protocol. Transport communication protocol, I think is what it is. And UDP is universal data packet. Why it's called universal data packet, I don't know. But the real difference between these two is if I have two machines and I need to send IP packets from one to the other, over some sort of an IP network of routers, et cetera. TCP has to be sure that the sender is going, or the receiver is going to receive it. So they're going to send information to the other computer. The other computer is going to send information back, and they're going to establish a handshake, meaning they know who they're talking to. And then the next thing that's going to happen is, the computer is going to send the IP packet over, and the computer 2 is going to acknowledge that the IP packet got there. So there's an acknowledgement step. With UDP, it's a little different. UDP, computer 1 just sends the packet to the IP address. No verification, no acknowledgement needed or requested, just sending it all day. In like secure communications, we need to guarantee that something is done. That's where TCP comes into place, where you need to guarantee packet delivery. In like robotic systems where we're trying to fly an aircraft, for instance, and we're sending information to an autopilot, it's usually UDP, because UDP is faster, and we just want the information to send. 5 time steps ago, I no longer care about that packet if it didn't get there. I only care about the packet that went now, and I just want to keep sending the latest. So those are the difference between those two. There's something called ICMP, which is really like a test mechanism, which is also sometimes lumped into protocols, but it's not what you actually use to send the packets. And then there's IP packets. Those are the actual pieces of data that you're sending, and we'll talk about that. And then there's subnetting, which gets into like, if I have one network, how do I isolate different portions of the network using something called subnetting. And then there's ports, which are, in the computer, the most based piece of the computer, the kernel. If you remember me talking about the kernel at one point, it has the ability to open ports, which allow you to send information. They're like virtual things, but they allow you to send information over ports to various pieces of the computer. Give me 1 second. I'll be right.
Networking stuff is definitely pretty useful here. Because Seco it's like all we're dealing with right now. It's crazy.
Is it UDP or TCP?
UDP.
Nice.
Mm-hmm.
I think like Link 16 operates like UDP.
Oh, really?
It just has like a time, like everybody has a slot, and like you're just broadcasting in the slot, and if it's your slot, you like consume it. So I imagine that's more UDP. I don't know. I remember Louis was telling me about it, but this is good background.
Yeah. All I know is it's a lot. It's a whole bunch.
By the way, I already told you, Jason, that Rachel and I are going to be out next week, right?
Yeah. All week next week?
Yeah, we're going to be in the vault for the Jester follow-on, right in the proposal. So it's got to be
We should probably tell Ron that to reschedule.
Yeah.
Okay. For Silvertip, I think it was just there's nothing special to cover, right? Just things
No,
recorded.
just running the meetings and the decision log, yeah.
Okay.
All righty. Back to action. Okay, so let's talk about tools for a second. Enet's a common library that's used in C++ to send stuff. Came out of the gaming community, which makes really nice things. So for a lot of different efforts I've been involved in recent years, people have used Enet to send IP packets over data links. There's also Wireshark. That's an important tool. It's an application that you download, and it will read all the packets that are flying across your network, so you can like debug stuff and kind of look deep into the weeds of like the IP packets to see if a particular message is working. Really good for debugging. Routers and modems, you guys probably have those at home for your internet, and wireless access points. That's an important piece to note, is that like if you're at home, when you're we're requesting a website or something, where the IP data packet goes is it goes from your computer over either Ethernet or Wi-Fi to the router in your home, or to the wireless access point. First off, if you're doing it Wi-Fi, to the wireless access point, and then to the router, and then from the router to the modem, and then from the modem gets transferred into all these baud rate signals that go to your ISP. Your ISP, your internet service provider, has all these routes all over the country, and they just like do all their magic to send it to another computer. And so that's kind of how that works. Those are 3 distinct components. Sometimes they're all in one, but you can actually buy them individually. And if you guys want to trick out your Wi-Fi setups to make them much better, talk to me after this, and I can tell you real cheap ways to like make your internet much better at your home.
Just
I need that. Yeah.
A lot of people don't know that.
I'm always cutting out. Yeah.
Oh,
Yeah. Are you on Wi-Fi, Justin?
I am. Yeah.
Oh yeah, we can hook you up, bro.
Sweet.
Actually, I bought another one today. But this is a commercial grade access point. It's Ubiquiti makes really cheap commercial access points that will outdo your neighbor's Wi-Fi and your Wi-Fi, and you can get a few of them and hook them up around your house, and they're an automatic mesh network. Much better than any consumer grade product you'll get, and your Wi-Fi will instantly be better. There's other nuances that we can talk about, like 5 gig versus 2.4 gig, etc. But okay, there's a whole world of networking. I actually know a fair amount of networking. Had to do a lot of debugging. Computer 1 sends information over Ethernet to maybe your hardware router, and your hardware router sends it over Ethernet to another computer. Typically, you see that in a SIL setup. Jason, you may have seen that very recently, depending on what you guys were doing. Packets get sent over a wire, basically, or some sort of a waveform. Now let's talk about briefly, and we'll get into this more next time, local area networks and wide area networks. So Local area network is anything that is like, if you have a router, like my router for my home, it's a local area network, and it has basically 2 IP addresses. It has an external facing IP address and an internal facing IP address. Every device in my home network, including my phone, knows that that router is like a particular IP address they have. Usually it's 192.168 dot why am I blanking? .001 but or 000. But you can always change it. I've changed mine to something else. There's like cybersecurity benefits, but it's really like unless you know what you're doing, it's probably 192.168.001. And then external facing is assigned by your ISP. So your internet service provider will, when you plug in your modem for the first time, like assigns an IP packet to you, or an IP address to you, that anyone in the world can access, which is why you don't want your external facing IP to be known publicly, because people can then spam your network. And there's a bunch of nefarious actors out there who will actually do that. If you're in like a YouTube video and you put like what your IP address is, like your network's probably going to get hacked or like degraded. And so that's usually a private thing that you don't want to release publicly, but internally, like all the devices don't know that. They just know what the internal one is. And then as it's going out, it flips from internal to external and gets sent somewhere else. So from a computer to a phone, wireless signal to a wireless receiver, which is a wireless access point, sends it, then connects over Ethernet or the same device through a circuit to your router to your cable modem over coax cable or fiber, depending on which one you have. I've had both, but now I have fiber, which is great. But it's still a signal no matter what. The difference is it's either electrons or it's light. And so it goes over a coax cable and then hits your internet service provider routers. And then there's a step here that's I'll quickly talk about in closing. If you are requesting a web page with a URL, it goes to something called a DNS server, which is domain name server, to change and resolve that IP address or that route or word text address into an IP address. And then it knows where to go and get data. So we'll cover this more next time. That's where we'll leave it today. But there's a whole process that gets close to like web development related to networking once you kind of get into it.